Okay, in your module 1, you learn about electric charge and also Coulomb's law. So in electric charge, we know the concept that like charges, for example, we have here positive, and also negative and negative. If we combine this one, it will have a result of repulsion. And if we combine unlike charges, positive and a negative charge, it will have a result of attraction between these two charges. And also we learn about Coulomb's law, and this Coulomb's law states that the electrostatic force is directly proportional to the charge between these two charges and inversely proportional to the distance between these two charges. So my question is, so what is causing this repelling or attracting force? So this is now our module 2. So this is electric field. So what is an electric field? An electric field is the area of force surrounding the charges. So this is responsible for all the influence that the charges have with one another. For example, we have here a positive and a negative. So let's draw an area of this positive, and for the negative, for example, it has a larger area than the positive. So actually this doesn't have a uniform strength. So how can we accurately represent this varying change in strength? So here comes now our electric field lines. This helps us actually visualize what is happening in an electric field. Okay, the strength of electric field is usually directly proportional to the length of electric field lines. So if we have longer electric field lines, we can now have a stronger electric field since we are talking about the area of a charge. And also, the direction of arrows of field lines depicts the direction of electric field. For example, in positive charge, the arrow would be pointing outwards. And for the negative charge, it's pointing inward. There. That is for the electric field lines of these two charges. And also, the magnitude of an electric field is well described by the density of charges. So for example, here, the lines closer to the charge, for example, here, the area here, and also in here for the negative. So since they are closer to the charge, this represents a strong electric field. And also the lines away from the electric field, for example, here, the lines here, this area, it has a weaker electric field. This is because the strength of the electric field decreases as we move away from the charges. And also, we can actually solve this is varying strength by using this electric field intensity or electric field strength, which has a formula of electric field intensity is equivalent to the electrostatic force divided by the point charge. And the unit for electric field intensity or strength, since the force has a unit of Newton, and for the charge is the Coulomb, so for the unit, it's Newton per Coulomb. Apply now our electric field intensity formula. So let's have here our sample problem number 1. So allow me to read. So when a 5 microcoulomb test charge is placed at a point, it experiences a force of 2 times 10 raised to negative 4 Newton at the x direction. So what is the electric field at that point? Okay, let's have now our given. So for the charge, the magnitude of the charge has a 5 microcoulomb, and that 5 microcoulomb, we can now convert that one into coulomb, which has the value of 5 times 10 raised to negative 6 coulomb. And also, the one given is electrostatic force, which has a value of 2 times 10 raised to negative 4 Newton. And for our unknown, it's electric field intensity. And the formula that we will be using is electric field is equivalent to electrostatic force divided by the charge. So let's now solve. So electric field intensity is equivalent to, let's substitute, electrostatic force has a value of 2 times 10 raised to negative 4 Newton divided by the magnitude of the charge, which has a value of 5 times 10 raised to negative 6. So using your calculator, just input this one, and we can now have a value of 40 Newton per coulomb. This is for number 1. So the electric field intensity at that point have 40 Newton per coulomb. Okay, let's have now our sample problem number 2. So allow me to read again. So if a microcoulomb test charge experiences a 10 Newton per coulomb electric field, so what is the electrostatic force on this charge? Okay, for the given magnitude of the charge, it has a 1 microcoulomb, and we need to convert this micro into coulomb, which has a value of 1 times 10 raised to negative 6. And another given, it's electric field intensity, which has a value of 10 Newton per coulomb. And for our unknown, it's electrostatic force. For our formula, we will be deriving the formula through the formula of electric field, which has a equivalent to electrostatic force times the charge. So let's cross multiply that one. So we can now have the formula for electrostatic force as electric field intensity times the charge. So let's substitute. So electrostatic force is equivalent to 10 Newton per coulomb times our charge, which has a value of 1 times 10 raised to negative 6 coulomb. So let's cancel same units. So we can now have the force as 1.0 times 10 raised to negative 5 Newton. So this is the force or the electrostatic force on this charge. It has a 1.0 times 10 raised to negative 5 Newton.